This conference will now be recorded.
Okay, in last lecture, we completed with what? Our chapter that is nothing but buffer. In that chapter, in part, we have seen what is your set buff function, set buffer function. So what actually they do? Set buff function, set buffer function. What they do actually? What actually they do? Set buff function, set buffer function, set line function, set line buff. For what they used? Set buff, set buffer, set line buff. Correct. To make unbuffered or for block buffer or to send the output to the terminal line by line. For this, we are going to use that functions. Okay. After that, we have seen the F first function. What actually F first function do? F first function do what actually F first function do? F purge. F purge. Delete input in the buffer. It will delete content of the input buffer. Others, whatever the content is stored in your standard input buffer, whatever the data is stored in your standard input buffer, it will erase all that data. It will delete all that data. That is what your F first function. After that, we completed the chapter and we started the new chapter. That is nothing but storage classes. In storage classes, we are going to study when you are going to create a variable. What are the properties of that variable? What is the lifetime? What is the scope of that variable? All the information regarding that variable we are going to discuss in this chapter. So in yesterday's class, we have seen a local variable, first variable, that is nothing but auto variable we have seen. So what is the lifetime of that local or auto variable? What is the lifetime? Lifetime of local or auto variable? Lifetime is nothing but what? When the block start and when the block end. At that time, the variable will be created at the block start, and when the block end, the variable will be deleted. Okay, that is the block. That is the lifetime of that variable. Then we are talking about scope. What is the scope of that variable? What is the scope of that local variable, auto variable? Yes, block scope. They have block scope only. We can access those variable only inside that block. We cannot access outside the block as they will be deleted. The scope is only the block. Inside that block only we can access that variable. If you are trying to access that variable outside the block, it will give error to you. Undefined variable like that. Okay, clear with this? First type of your local variable, that is nothing but auto. Now let us see the second type of your local variable. Second type of local variable. Local variable means what? When the variable is going to create inside the function, that variable is nothing but local variable. There are three types of variable you are going to declare in the inside the function generally. One is a auto local, second is a register variable, and third is a static local. So yesterday we completed auto. Now second type is a register variable. Register variable. Register variable. As the name suggests, register variable is nothing but, as the name suggests, if I am declaring the variable using the register keyword, it means that I am asking to compiler that allocate the memory for variable in the CPU register. Allocate the memory for the variable in the CPU register. Till now what we have seen? Till now what we have seen? Where you get the memory? Where you generally get the memory for your variable? Where you get the memory for your variable? Yesterday I discussed. In code segment, you will not get memory. You will get a memory either in a stack, either in a heap, or either in a data segment. Only in these three segments you will get a memory. For local variable, you will get a memory in a stack only. For local variable, you will get a memory in a stack only. But if we see all these data segment, stack, heap, code segment, they are all in a RAM. When you are going to execute the code, all they are in the RAM. All they are in the RAM. If we want to declare any variable, they will be created inside the RAM only. Means inside the stack means what? Inside the RAM only. If you want to use that variable, if CPU want to use that variable, if CPU register want to use that variable, whatever the values at that variable, if CPU want to use that variable, at that time what will CPU will do? CPU will go to the RAM. CPU will go to the RAM. It will search for that address. After searching that address, it will find that address. From that, it will fetch the value and again return back to the memory location. So it is taking somewhat extra time for execution of program. It is taking somewhat extra. It will take some delay. So because of that, what I am saying that I am adding register keyword to the variable. So that I am saying that please, I am saying that create a variable inside the CPU register only. So that whatever the timing for going to the RAM memory and coming back, that RAM time will be saved. Directly your variable will be created in the CPU register. So no need to go to that RAM memory. That is what meaning of your register. To create a variable inside the CPU register. To allocate a memory in a CPU register. But it is just a request. It is a request only. It is a request. Highlight this point. It is a request. Okay, it is a request. If you are adding register keyword, it means that we are requesting only. Please allocate the memory for my variable to the CPU register. I am requesting. I am just requesting to the compiler. Please allocate the memory for my variable in the CPU register. Request means what? It may be grant or it may be not grant. CPU may be grant that request or may not be grant. It will depend on the compiler and the system to allocate the memory in CPU register or not. It will be totally depend on your compiler and system. They will decide whether this variable will get the memory either in a CPU register or in your stack. Suppose they granted your request. If request is granted, at that time they will allocate the memory in a CPU register. But if your request is not granted, then what will happen? The variable will be created in the stack only, means like a normal variable. It will be created in the stack only like your normal variable. So register keyword is used to request a compiler to allocate the memory for variable in a CPU register. Once again, I am saying register keyword is used to request a compiler to allocate a memory for variable in a CPU register. But when you are going to execute on runtime, it will decide whether to get a memory for this variable, where to give this memory for this variable. It depends on your code only. Suppose I am declaring one variable as a register. I am declaring one variable as a register, but that variable I am not using most of the time in a program. I am just using that variable only for printing. I am not doing with that anything with that variable. So your compiler will say we'll see that as this variable is not used that much, so no need to waste our memory in the CPU. So it will not allocate the memory from CPU register. It will not give memory in the CPU register. It also depend on how you are using the variable. If that variable using most of the time in your program many times, at that time memory will be granted. This is what idea of your register keyword. But one drawback is that But one drawback of your register keyword is that we don't know whether our request is accepted or not. We never know whether our request is accepted or not. We don't have idea about this. We are just requesting. We don't know whether we are getting memory from CPU or whether we are getting memory from your stack. That is the drawback of your registered keyword. We don't get idea about. We never know whether we are getting a memory from a CPU register or a your stack. That is only the drawback of your register variable. So to get a memory from the CPU register, it will totally depend on your code. It will depend on your compiler. It will depend on your system. Actually, in an advanced compiler, now most of the compiler used in company are nothing but they are advanced compiler. Even though if you don't add a register keyword, even though if you don't add a register keyword in for the advanced compiler, they will identify the variable as a register. They will see how variable is using it, how many times variable is used in the program. They identify on their own. If that variable is used many times in the program, so what latest compiler will do? They are very intelligent. They will try to optimize the code. They will try to reduce the execution time. So automatically they will create a memory for that variable inside the CPU register. This is what idea about your register variable. The behavior of the variable is totally similar to your normal variable, auto variable. Exactly similar. Only difference is that either they can be get a memory from the stack segment or either they will get from the memory on the CPU register. Lifetime and scope, everything will be same like your auto variable. Lifetime will be what? When the block start and when the block end. And scope is what? That block only. If you see the table here, if you see the table for register variable, see here, if you see the register for this variable, for register, scope is block only. Lifetime is between the block entry and exit. And memory for this is nothing but either it is getting from the register or either it will get from the stack. For auto, always it is going, we are getting memory from the stack. For auto, always we are getting the memory from the stack. But for register, either we can get from the register, where in the CPU, or either we are getting from the stack. It will depend on the compiler. All remaining behavior, all the access property and everything will be same as your auto variable. This is what your register variable is. All of you clear with the register idea about clear register variable? Clear? All of you got the idea about register keyword? What happens if you are doing adding register keyword? Sometime in interview they will ask about register keyword. What will happen if you are adding register keyword? Just it is just a requesting. It is just a requesting to the compiler to give a memory for my variable in the CPU register. Okay, and one thing about your CPU register, one thing about your register variable and auto variable. Okay, one thing about your register variable, register and auto variable. If they simply declared, if they simply declared, it means what? If we are declared like this, int x, suppose this is inside the function, if I am declaring like this inside one function, suppose I am writing the function int main. Suppose I am writing like this int main. Suppose I am declaring a local variable here, auto variable here. Okay, and I'm declaring another variable register y, register int y. Okay, it is nothing but what type of variable it is? It is nothing but auto variable. It is a register variable. So for this variable, definitely you will get a memory from the stack. For this variable, definitely you will get a memory from the stack. But for this variable, you can't say where you are getting the memory. Either you will get a memory in the CPU register, or either you will get a memory from the stack only. So if you simply declare, so automatically what will happen? They will contain the garbage value. They will contain the garbage value. When you are going to print x and y, they will print any garbage value. Both your auto variable and your register variable, both will contain garbage value if they simply declare only. Clear with this? Clear with this point? All of you clear with this thing about register keyword? Guys, cleared? Let us see some examples. Okay, about register keyword. Now tell me what will happen here. What will the output of the code? Whether it will give error or not. Will it give any error? What do you think? See here. Here I am declaring a variable as with the register keyword. Okay. Here I am declaring the variable as a register keyword. So it means that either this variable get a memory from the stack, or either it will get the memory from the CPU. In the next step, what I am doing? In the next step, I am doing %i. In the next step, I am doing %i. Means what I am doing? I am paging the address from the CPU. I am paging the address of this variable. Means what I am doing? I am paging the address of the CPU. It is possible to page the address of CPU? If you are trying to page the address of CPU, CPU will stop the process. CPU will stop the process. So it is not possible to page the address of the CPU. You will say like that. We don't know. Sometime it will get a memory from the stack also. So at that time it will work. But what will happen? Your compiler will always think that this variable is getting the memory from the CPU only. So you at that point, it will give error. It is not like that. Sometimes it will give error or sometimes it will not give error. Always it will give error. If you are declaring the variable with a registered keyword, so compiler will always think like that. This variable will get the memory from CPU only. So it is not possible to fetch the address of the CPU. So at this point, it will throw the error. Understood? So it is not possible to fetch the address of CPU. Clear with this example? Sometime in interview or placement test, this example may ask such type of example. Clear with this, guys? Only one student is responding. Others, what about others? Guys, please reply. Okay, let us try the next example. Now tell me, this is possible or not? Will it execute or not? What it is going to print? What do you think? What it is going to print? Correct, Koni Reddy. Koni Reddy is correct. Pone is correct. 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 What we are doing here? What we are doing here? Here we are adding %. Here means we are trying to fetch the address of a I variable and trying to store here, but your I variable is nothing but it is a register int. Means sometime it may get a memory from the CPU, but your compiler will think like that it may get from CPU only. So because of that, your compiler will throw here. Your compiler will cannot fetch the address of I variable, register variable. See here, you cannot fetch the address of the register variable. Write it in the bold. We cannot fetch the address of the register variable. So here I is the register variable and we are trying to fetch the address of the register variable. So because of that, it will give a error to you, compiler error. So it will not execute. Clear? Next example, 11. Now tell me this, what will happen here? Now I am creating a I variable. This is auto variable, but I am creating a pointer, which is a register pointer. Will this give any error or what? What do you think? Variable I is a local, pointer J is a register. Is it possible? What will the output? I address. Who is saying I address? Why Koni Reddy? Okay, 10. Banu Prakash, Aniruddha, why error? Banu Prakash and Aniruddha, please explain why error. Register int J cannot be accessed. See here, what I am accessing here. Actually, what I am accessing here. I am creating a point. I am creating the variable I. I am creating the variable I. Suppose this variable is going to create in the stack. I am going to create the variable I. This variable is going to create in the stack. And we are storing a 10 there. Suppose the address of variable is nothing but 100. Suppose the address of variable is nothing but 100. Now we are trying to fetch the address of I. Means what we are doing? We are trying to fetch the address of the local variable. Not what I am saying, not local. I can say that I am fetching the address of the variable which is created in the stack. This variable is not going to create in the CPU. This is auto local variable. It is going to create in the stack only. So it is not error. So what will happen? And percent I will fetch the 100 here. So in a J pointer, 100 is going to store, but this J pointer is in a CPU memory. This J pointer is going to create in the CPU memory. In that CPU memory, 100 will be stored. Inside the J variable, 100 will be stored. And we are trying to dereference that 100. Means we are trying to dereference the 100. Means we are trying to dereference the stack memory. We can dereference it. So it will not give any error. So it will give you what? It will print only 10. It is going to print only 10 only. It is going to print only 10. Clear with this, guys? Understood? Koni, what is his name? Anirudh. Clear with this? Now let us move to the next part. That is nothing but next type of variable of a local type. That is nothing but local variable. Static local variable. Static local variable. How will you identify variable is a static local variable? Already we have seen this. Already we have did some example. How will you identify? Auto variable and both auto variable and register variable both will store the garbage value. If you simply initialize, Saurabh, both will store garbage value only. It can be 0, 1, 2, 1000, 10,000, anything, any value they can store. Now tell me, how will you identify whether your variable is static or auto? How will you identify? So when you are going to declare a variable inside the function, so whenever you are going to declare a variable inside the function, by adding a static keyword, to it, it means that the variable is a static local variable. If you are declaring the variable inside the function by adding a static keyword to it, it means that the variable is nothing but it is a static local variable. So here, suppose I am creating a variable like this. Static int z equals to z. Okay. So if you are declaring a variable inside the function by adding a static keyword to it, it is nothing but it is a static local variable. So can you tell me, from memory segment, when you are going to execute the code, from which at that time we are going to create a four memory segment will be created. So from which memory segment static variable will get the memory? From which memory segment it will get the memory? Yes, it is going to get a memory from the data segment. It is going to get the memory from the data segment. So can you tell me what is the lifetime of that variable? What is the lifetime of variable as it is getting memory from the data segment? So can you tell me what will be the lifetime of the variable? What is the lifetime of the variable? As we know, data segment will be in your program until your program is in execution. Till your program is in execution, your data segment will be there only. So I can say that the lifetime of any static local variable is nothing but it is a till program terminate, till program is in execution. And what do you think? What about scope? What do you think? What about scope? Scope will be program. Suppose I am declaring another function. Suppose I am declaring another function int fun. Okay. If I am trying to use the variable, if I am doing like z equals to 10, I am printing the z. Will it work? Will it work? Will it work? We have seen this example in a functions. Can we access the variable like this? We have created z here. So in a I have created z in a main function. So can I access here? Can I access here? No, you can't access. You can't access because for every local variable, scope is always blocked. Scope is always local. Scope is always blocked. That is the speciality of your local variable. Whether it is a auto local, whether it is a register variable, or whether it is a static variable, scope is only the block. Scope is only the block. Okay. So if you see the slide 408, you will observe here for static local variable, the scope is only block for all the local variable. For whether it is auto, scope is a block. Whether it is a register, scope is a block. Whether it is static, scope is a block. That is the speciality of your local variable. Scope is always a block. When we are talking about the lifetime of your local static local variable, lifetime is nothing but between the program start and end. Between the program start and end means program is in execution. And memory allocation is the data segment. Memory for the variable will be created. That variable will be created in the data segment only. That is what speciality. Understood this static local variable, lifetime scope, lifetime and scope. Everybody clear with this? Remember, for every local variable, any type of local variable, scope is what? Scope is always a block only. Scope is always only a block. Always only the block. Clear with this? Now, if I am going to create a variable like this without initializing, if I am going to create a variable like this, what do you think? What value will get? What value will be assigned? For local variable, for auto variable and register variable, garbage value will be there. But for static variable, what will be the value? Will be assigned to it. What do you think? What value will be assigned to the static variable? So to understand about this, let us understand data segment in detail. As we know, the memory for any static local variable, it will be created in the data segment only. It is going to create in the data segment. Suppose this is what your data segment is. This is what your data segment is. This is your data segment. Your data segment is divided into two parts. Your data segment is divided into two parts. Okay. The first part is called as initialized part. The first part is called as a initialized part. And second part is called as uninitialized part. Uninitialized part. Okay. So when you are going to declare a static local variable, when you are going to declare a static variable, static local variable with initialization, suppose I am declaring like this: static int x equals to 10. Static int x equals to 10. Then for that variable, memory will be get from the static initialized part. Sorry, it will be get from the initialized part of your data segment. Memory will be get from the initialized part of your data segment. So here x will be created. Sorry, I will take you another name. I will take a. So memory will be created here only. Memory will be created here in the initialized part. If you are declaring a variable, if you are at the time of declaration, if you are initializing the variable, at that time memory will be created from the initialized part of your data segment. But if you are just simply declaring, you are not defining, you are not initializing, at that time memory will be created from the memory for the z will be created from the uninitialized part. So z will be created in the uninitialized part. So memory for the z will be created in the uninitialized part. The speciality of this uninitialized part is that the speciality of this part is that every every bit of this memory, every bit of this uninitialized memory is filled with the zero only. That is the speciality of your uninitialized part. Every bit of this memory is filled with the zero. So as it is going to create here, as this z variable is going to create here, because of that z will be what? Z becomes zero. Because of that z will become zero. Understood? That's why z, when you are going to create a static variable, when you are going to create a static local variable without any initialization, they will assign a zero directly, because they are going to create in an uninitialized part of your data segment, and each bit of your data segment, the memory of that data segment is filled with the zeros only. And this part is also called as a BSS. This part is also called as a BSS. BSS. This part is also called as a BSS. BSS is nothing but block started by symbol. Block started by symbol. Understood? Understood this thing? Everybody clear with this thing? Where we get the memory for static variable without initialization. Okay, remember whatever the things I am going to tell in this topic, it is the most important topic for the interview. There will no interview without storage class question. There will be no interview. Every time question will be asked in the from the storage class. After the placement, when we talk with the student, they always say most of the question are came from the storage class. Every time, they for every company, most of the company will ask only storage class. So be clear with all the concept. Why we are getting here? Why JD is assigned as 0? Understood what? Whatever the things I told, clear with this? Everybody clear? So let us see some example. Okay, based on the, let us see some example. Now tell me for answer for this one, what will happen here? In the last example, so we observe example number maybe 2, 3, maybe 3. Example number 3. At that time, what happened here? What answer? What output it has given for this example? What will the output? For this example, what will the output? It is giving a error, segmentation fault, or sometimes it will go a garbage value. Means what? Undefined behavior. Why? Because here we are returning the address of the local variable. In this example, we are returning the address of the local variable. When you are going to return an address of a local variable, at that time that variable may be deleted. That variable is going to delete. So when you are trying to dereference that variable, at that time it will give error, it will give undefined behavior. At that time it will give undefined behavior. J will be discarded, means what? Okay, at that time J will be deleted. So if you are trying to dereference it, at that time it will give error to you. But suppose here I'm just printing the value of I. I'm not printing the star I. I'm just printing the I value. Will it give any error? If I'm just printing the I value, I'm not printing the star I. Will it give any error? It will not give any error. It will not give any error. Why? Because you are not dereferencing it. It will not give any garbage value. It will give the address of that I only. Suppose I'm saying that address of I is 100. Suppose I'm saying that address of I is 100. So what do you think? What will it print? If I'm just printing I, I'm just printing I. What do you think? What it will print? So in this foo function, I'm going to create an I variable. Correct? So address of that I variable is I am considering 100. Okay, that 100 I am returning to this function. Means now this I will contain 100. If I am trying to dereference it, that 100, at that time it will give error because we cannot dereference that another memory. But we can print the address, na? We are not dereferencing the address, any memory. We are not accessing any memory. We are just printing the value of that address. We are not dereferencing that address. So it will not give any error. So printing of address is possible. But dereference is not possible. You can print I. I will print 100. But if you are doing star I, means you are trying to dereference star 100. If you are trying to reference address 100, so at that time it will give error, segmentation fault. This is called as a runtime error. Understood? Segmentation fault is called as a runtime error. Or sometime it will give undefined behavior. So when such type of a question will came, at that time you must reply undefined behavior. At that time you must reply undefined behavior. Okay, I will execute this code. Sometime it will give garbage value also. This is what example is. Okay, if I'm going to execute this code, let us see what will happen. See what it is printing. Now it is giving answer. Now it is giving answer. But sometime it will give a segmentation fault. Sometime it will give a segmentation fault. We cannot define behavior of this question. That's why we are saying that undefined behavior. Currently it is giving answer. But sometimes some compiler will give error for this. Some compiler is going to give error for this. We cannot define. Always it is going to give a 10. Sometime it will give a segmentation fault also, because that memory will be assigned to some other process also at that time. Currently this memory is not assigned to any process. Currently whatever the where we are storing the I here, this memory is not going to assign to any process. Because of that it is printing 10. But when this memory is going to assign to some other process, at that time it will give segmentation fault. So we cannot say. Otherwise it is going to give 10. Sometime it will give segmentation fault. Correct stack will be deleted after coming out of the function. Because of that, whatever the address, whatever the things we are going to create it there, they will, for that we don't have access. Now sometimes memory is free there. We have printed from the free memory. It is not given for any process. It is not given for any process. That's why we are accessing it. But if you are, it is suppose this memory is given to any other process. At that time, if we are trying to access it, at that time it will give error. Understood? And if here I am trying to print the value of I, at that time you don't say undefined viewer. So it is going to print the value of address only. It is going to print the address value only. If such type of question here came, at that time they will give the address of I variable. This I variable, they will give the address. So at that time you need to print the output, like suppose they have given address like this. Suppose I am writing like this. Address is what? Address of I is 500. So tell me what will the output? What will the output? Output will be 500, correct? Output will be 500. Now here what we are printing? We are printing the I. We are printing the address. Maybe we don't have access on it. Maybe it is given by some other process. But we can print that address. But we cannot dereference that address. We cannot access that address. Understood? Now when we talk about this question number 10. What happened, Anirudh? Actually, when you are going to return from the stack, at that time stack, that address will be in your memory, RAM memory. Anirudh, remember, we can print any address of your RAM memory. We can print any address. From your RAM memory, we can print any address. But we can only access the memory on which we have access, which is allotted for our process. We can print any address of our memory. Understood? We can print any address of your memory, but we cannot access, we cannot dereference every address. We can only access the memory which is given for our process. At that time you will get, just a minute, I am printing the address here. So what should be the I is nothing but I is containing the address. So what should be the here? It should be P, or it can be it is printing the address of that variable. This is what the address. You can print the address. You can print the address. Understood? You can print the address. Any address you can print. Remember such type of question, it may be asking your objective test also. You want to see the code. See the code. Now let us see the example about your static variable. Static local. Okay, this is the first example. Now tell me what will happen here. What will the output? What will the output? I'm asking output. This is what Atul Raj is correct, Babu is correct. Reply everybody. Others. Reply fast, you have 1 minute. Whether it will give undefined behavior or it will give 10. What do you think? Whether it will give undefined behavior or 10. What do you think? Correct, it will give 10 only. It is going to give 10 only. Why? Because we are creating this I variable. We are creating this I variable. Okay, where the memory will be created about this I variable? Where the memory will be created about this I variable? No one specifies the address. No one knows the address of variable. Kalyani, no one knows the address of variable. I'm just giving example there. No one knows the address of the variable. It will be given by your CPU only. Only CPU knows the address of the variable. Tell me here, what will happen here? Where this is going to create? It is going to create in the data segment. Okay, suppose this is what your data segment is. In a data segment, I will be, so I'm first, I will trust, these are DS. Data segment. Okay, suppose I'm going to call a main function first. Okay, I'm going to call a main function. In main function, I'm going to create a pointer. In that pointer, I'm going to store the value which is written by foo function. So as I'm going to call a function, this is a main stack. Okay, as I'm going to call a function foo, stack will be created. Stack will be created, correct? At that time, stack will be created. Now what I'm doing in that function, in that stack, I'm going to create a variable I, but it is a static. It is static. So memory for this I variable will be created here, where in this stack or in this data segment. In the data segment. So this I equals to 10. I equals to 10 will be created here. Suppose the memory for variable is nothing but I'm taking 100. Suppose memory is nothing but I'm taking 100. I'm taking it as a 100 only. Okay, so what I'm doing? I'm creating a J pointer. I'm creating the J pointer. inside the j pointer I am storing the address of I. I am storing the address of I. So this j pointer will be created where n inside the data segment or inside the stack. This is a f stack, foo function stack. This is a foo function stack. So this j variable is going to create in the stack only. So this j variable is going to create in the stack. So in this j variable, what we are storing? We are trying to store the address 100. We are trying to store the address 100. So 100 will be stored here. Address 100 will be stored here. Correct. Now what after that? What I am doing? I am returning the j. Means what I am doing? I am returning the address j. I am returning the 100. So when I am going to return, at that time the stack will be deleted. This stack is going to delete, and that 100 is going to return. So this data segment will be deleted. Can you tell me this data segment will be deleted? This data segment is going to delete? No, it is not going to delete. I variable will be there. Whatever we have created, everything will be there. Now this I contain 100. Now this I contain 100. So what I am doing? I am trying to dereference that I. I am trying to dereference the address, whatever the address contained in the I variable. I am trying to dereference. So I contain the address 100. I contain the address 100. So I am going to dereference that. So I am going to the address 100 and I am going to dereference it. So because of that, it is going to print 10. It is going to print 10. Output will be 10 only. Understood? Now clear everybody? Everybody clear with the example? Okay, let us go for the next example. Example number 13. Now tell me what is happening here. What it is going to print? Error or what it will print? Will it give any error? If it is giving any error, why? And it is printing any output. So tell the output and why it is printing. Correct, Jayant? Only hello? Aniruddha, only hello? Percentage will keep printing until it is getting null character. Remember. Only for reading is there. When you are going to read the percentage, at that time it is going to read up to the space. But for printing with the percentage, it is going to print until you are getting the null character. Understand the difference between this. When you are going to use percentage in a scanf function and when you are going to use percentage in a printf function. So it is going to print hello world. Why? Because this CA, this character array is going to create in the data segment and that data segment will not be deleted. If you are trying to access that data segment, if you are trying to that array using the address, if you are trying to access that array using the address, we can access it. But with the variable name, we can't access. If you want to access with the variable name, at that time scope is what? Only this block. Inside this block we can access. With the variable name, you can't access here. If you want to access with that array, we can access with the address. Understood? Next example. What is the output? Babu, let's see. Again see here. Now variable is a static int. Not already discussed. Uday, it will print 2 times output. Correct. It is going to print what? It is going to print 2. So can you tell me when this line is going to execute? When this line is going to execute? At what time this line is going to execute? At what time this line is going to execute? No, Kone Reddy. Swagata correct. No, you are forgetting everyone. You are forgetting everything. It is going to execute only at the compile time. It is going to execute only at the compile time. And remember, it is going to execute only at the compile time. When we are going to execute at that time, this line will be not executed. At runtime, this line will not be executed. Only at the compile time, the memory for the ticket stored will be created in the data segment, because data segment is created at the compile time only. So memory for the data sold, the ticket sold will be created at the compile time only. After that, it will not be, this line will not execute. So what will happen at the compile time? This data segment will be created here. This is what data segment. It is a data segment. A data segment. Okay. At that time, t variable is going to create. Suppose I am taking t. It is equals to 0 now. At that time, compile time. When you are going to execute the code, first time you will go to the main function. So main function will be called here. Main stack will be created here. Main stack will be created. So I am creating the count variable. Initially count contain the garbage value. So I will not take that. Initially count contain the garbage value. I am not going to take that because I am going to assign the another value here. Okay. So I am going to call the book function, book ticket. So as we are going to call the function, I am going to here book ticket. I am going to come here. Correct. So will this line execute now? Will this line execute now? First line static in for ticket. So now it will execute. No, it will not execute. It will execute only once at the compile time only. So because of that, what will happen? It will come here. Ticket sold. Directly your control will come from here only. Direct ticket sold. So we are going to increase the value of ticket sold. So ticket become what? It will become 1. It will become 1. Correct? And we are going to return the 1. Now initially the count contain 1. Initially count will contain 1. Again we are going to call the function ticket sold. Book ticket. Again we will come here. Will again this line execute? Will again line this execute? No. Again we will execute this line. Again we are going to increase the value of ticket. So it will become 2. It will become 2. And I am going to return the ticket sold. So now I am going to return 2. So ticket, this count contain now. This count contain now 2. So it will print what? It is going to print 2. Clear with this? Understood? Everybody clear with this? Now next example. Example number 15. Tell me the output for 15. All of you draw the stack for example number 15 and 16. Take your time. Within a 5 minute, tell me what will the output for example number 15 and example number 16. For both the program. You have objective test on Sunday na? So you should know this question. This is example of recursive function. So I am expecting answer from you. I will see how is your preparation is going on for objective test 2. Tell me the answer for this question and tell me the answer for this question. Saurabh, what I am saying, for auto local variable, it can get any answer. Sometime it will, you will get a 0 also, 1 also, or any garbage value also. Not every time it will, you will get 0. It may be changed every time. It is a garbage value. That's why we are saying garbage value. It can be anything. 0, 1, 2, anything. No, not always 0. It will be anything. It will be a garbage value. Now try to solve this example number 15 and 16. Take a 5 to 10 minutes you can take, but just reply me. I am expecting answer from you for both the question. For both the question, I am expecting answer from you only. See the question properly. Take your time. Tell me both will same, say both will same print same output or what? Please reply everybody. Koni Reddy, you are correct for both the question. For 15 and 16, both answer are correct. Others, are you not practicing for segmentation fault and 4? No, no Sunil. First is correct. Koni Reddy, you are correct for both the question. Vedang is wrong. Babu correct. For first question, Saurabh is correct. Lokesh, you are correct. For both the question, you are correct, Lokesh. Bhanu Prakash correct. So see here, what will happen? What will happen for this example? Suppose I'm going to execute, I will execute the code. Not execute, I will explain the code here on WSL. Sorry, journal. So this is what my code is. This is what my code is. So what I'm doing, this is an example of a recursive function. As I'm calling main function inside the main function. This is nothing but it is a example of a recursive function. It is nothing but it is an example of a recursive function. So tell me what will happen. First of all, main stack will be created. First stack will be created, which is called by your operating system. Which is called by your operating system. Suppose this is what main stack created. Okay, in that I am going to create a variable I equals to 5. In that I am going to create a variable I equals to 5. Okay, what I am doing after that, I am doing I minus minus I. I am doing minus I. Correct? I am doing minus I. Means what? I am doing minus I means what? Now tell me this I is going to create in the main stack or data segment. Just tell me this I is going to create in a main stack or data segment. Yes, it is going to create in a data segment. So this variable is going to create in the data segment. No one replied for that. If I'm going to create there I was created. Here data segment. In a data segment, I is created as 5. I is created as a 5. Now I'm doing minus I. Because of minus I become 4. Because of minus I become 4. This line is going to execute only one time at the compile time only. This line is going to execute at the compile time. Now this line I am going to eliminate. Because that is going to execute only one time. Now I become 4. Correct? I'm going to call the main function again. Again, I'm going to call the main function. So because of that, stack will be created. Another stack will be created. For this function, I value is what? Another for now, a stack is created. Again, in that stack, what I'm doing? Again, I'm doing minus I. Again, main stack will be created. Again, I'm going to execute the function from the starting line. Again, I'm going to reduce the value by I become what? I become 3 now. I become 3. So here 3 is coming, condition become true. So again, I'm going to call the main function. Again, stack will be created. Again, stack is going to create here. Again, I'm as stack is created. Again, I'm going to execute the line start from the starting. Again, I become reduced by 2, 1. I become 2. See, in the same way, I will what? Keep creating until what? Until I am getting I value 0. Until this condition falls. So when now I become 1. Now I become 1 here. Now again, what will happen? Again, stack will be created. As I am doing minus I. As I am doing minus I. So what will happen? I become 0. And I become 0. And it will return 0 here. It will return 0 here. It is going to return 0 here. So condition become false. Because of that, what will happen here? It will directly jump to this point. It is going to directly jump to this point. It is directly jump to this point. So it is going to print. It is going to print what? This tag is going to print what? It is going to print 0. And after that, what will happen? After that, what will happen? It is going to delete. It will be deleted. And it is going to the point where it is called. It is going to in this function where it is called. So it is called here. So it will come here. After that, there is a line print I. So it is going to print what? It is going to print here. It is going to print 0 here. Again, it will be delete. Same thing is going to happen here every time. 5 times 0 will be printed. If for this question, 5 times 0 will be printed here. But in the second example, second example, what we are doing? In the second example, after returning from the stack, we are directly closing the stack. We are not going to the next line. Here we are going to next line because what? Because there was no return keyword. Because there was no return keyword. Because of that, we are going to execute this line for every function. Because of that, we are going to execute this line for every function. But this line will be executed only when your I value becomes 0. Only for that, this line is going to execute. and only for that 0 is going to print. For remaining function, stack will be deleted at this point because of this return keyword is here. So that for this question 0 will be printed only once, and for this question 0 will be printed 5 times. Understood? Clear? Now tell me this question. Answer for this question. What is the output? Is it possible? Will it give any error? Or what? What will happen here? Will it give any output? Okay, I'm going to execute this code. See, this is what example is. See, this is what example is. Now Anirudh, it is visible now. Okay, this is what example is. I'm going to execute it. See, it is printing what? Initializer element is not constant. What happened here? What do you think? What is the reason? In a last example, I told you that this static int x, it is going to execute the line. This line is going to execute it at the compile time. Correct? This line is going to execute only when at the compile time. At the run time, this will not execute. Correct? Correct? What I'm saying, this line is going to execute at the compile time. What I'm saying, correct or wrong? It is correct. This line is going to execute at the compile time only. But at compile time, tell me this function will be executed or not? When this function is going to execute? When this function is going to execute? At the compile time or runtime? It is going to execute the runtime only. It is going to execute at the runtime only. So can we store the value? This function is returning our value at the runtime, and this function is to executing at the compile time. So can we execute this line? No, it is not possible. So because of that, always when you are going to create a variable, with a static keyword, when you are going to create a static local variable, always store a constant value. Remember, always store a constant value. If you are trying to store any variable value, it will give you an error. It is going to give you an error because this function is only, this variable only contains a constant value, as it is going to execute at the compile time. Because of that, we can only store a constant value. If you are trying to store any runtime value, any runtime variable, at that time it will give any error, because if you are trying to store any variable at the runtime, variable value will be changed. Because of that, static local variable always store a constant value. Understood? Understood? If I am creating variable like this, int I equals to 10, if I am doing like this, is it possible or not? Tell me. Is it possible or not? Why it is possible? Aniruddha, tell me, when will this I will create? When will this I will create? I variable, when it will create? It will create at the runtime. And your static variable is going to create executed at this line is going to execute at compile time. So is it possible to store a value? Not possible, because this I variable is going to create at runtime only. This I is going to create at the runtime only. When you are going to call the stack, main stack, at that time this I is going to create. When you are going to call the stack at the runtime only, this I is going to create. And this statement is going to execute what? At the compile time only. Because of that, it will give an error to you. If I am going to execute this code, see, again error. Initializer element is not constant. Initializer element is not constant. Understood? It will give error to you. Will int x equals to foo? Oh, yes, it will it will print foo, because x is going to create at that time. Int x is going to execute when? If you simply write int x, if you simply write int x equals to foo, both are going to create at a runtime. So both will create. This x is created first. Because of this, it is a main stack. This x will be created first, and as foo function is called. After that, stack will be created. That stack will return the value. After that, we are going to store, and after that, this line is going to execute. So this is possible. We have seen that like that only. Many example we have seen. Full function chapter we have seen like this only. Still you are asking. Understood? Clear with this thing, guys? Any doubt? So let us see some more example. Is there any? Example number 18. Now tell me answer for this thing. It is going to print 10 because it is a static variable. It is a static variable. It is going to print 10. It is going to, we can return the address. We are returning the address of a static variable. We can dereference using the address. As it is going to create a data segment, so it is possible. So it is going to print 10. Now tell me for this question. Question number 19. It will give undefined behavior, correct? Undefined behavior. I already told such type of question came. Reply undefined behavior, not error. Undefined behavior. Why? Because what we are doing here, we are storing the address of the local variable here. So j will contain the address of the local variable, and we are returning the j. Means what will contain in the j? We are returning the address of the local variable, because j will contain the address of local variable, and we are returning the j. Means what we are doing? We are returning the address of the local variable, and we are trying to re-reference that local variable address. Because of that, it will give undefined behavior. Because of that, it will give undefined behavior. Understood? Clear with this? All of you clear with the local storage class? Clear with all of you? Clear with the local storage class? Any doubt in this local storage class? Auto variable, register, and static local. In three variable, any doubt? Okay, we will stop for the for today's session here only.
This conference will now be recorded.
It will give error at the compile time. Why? Because where is that example? It will give error at the compile time. This 19 example will give error at the compile time. Why? Because we are trying to store the variable address which is created at the runtime, and this line is going to execute at the compile time. Because of that, it will give error at the compile time only. It is a compile time error. It will not give any undefined behavior. And when you compile the code at the time, it will give error. Understood? Again, any doubt, others? Any doubt now? In a 18, what will happen if we try to return a value of I? Means what? If you are trying to return the value of I, means what? This is I value. Okay, I equals to 10. This you are asking. Jayant, if you are returning I value, and if your return type is an integer, at that time it is going to print I value. Means whatever the variable, if you are storing this I value in a some variable. Suppose in the I variable I am storing the value, and we are returning I. Suppose return type is nothing but only int I. I am creating variable as a int I. Suppose I am creating instead of instar I. Suppose I am creating the variable int I, integer I. So what I am doing, and your return type will be at that time return type will be integer. If you are trying to return the value of I, at that time return type will be integer. So it is going to return 10 there, and that 10 will be stored in the integer I, and we are going to print I, so it is going to print 10 only.